structure is a way of storing and organizing data according to certain formats or structures. So you see very explicit set of rules, right, surrounding the use of lists, also surrounding the use of dictionaries. These are data structures, but also data types, okay? When I say data types, they are specific to Python, but when you turn them into a data structure generically speaking is something that has been around for, I don't know, close to 70 years, since the 40s, right? For example, your dictionary in Python, it's really a hash table. Hash table has been around since the 50s, since the advent of the current modern computing. It's been around for a long time. These things, allow you to, so I'm talking about when I say these things, these principles for each of these data structures allows you to store and also retrieve data. And that's basically it. They serve different purposes. And for the general purposes of storing and fetching data, one is faster than the other, depends on the situation. So for example, if I'm working for Google and Google is asking me to code some backend logic for serving data in search. And as you know, Google search is the bread and butter for Google. And if you come up with an algorithms or data structure that is so slow, you'll be fired. Google is going to be out of market, and someone else will take over Google. So that's not good. This is the reason why when we are looking at data structure and looking at ways to store data and serve data, that you want to be mindful of the efficiencies and the reason. You have to reason this out. Like, why am I using this over the other? So one example is, hold on a second. Yeah, one example is list, right? So list is immutable, right? Meaning you can store something in the list and modify it later on. But the fact that you can modify things in the list makes lists slower than, for example, Tuple. Tuple is something that cannot be changed. Dictionary, you can change, it's immutable. But mutable and immutable, the differences between the two is if you make something that is immutable, that means it's got less features associated with it, methods associated with it, than another data structure that is immutable. Because when you're dealing with something that is immutable, you have to also allow for inserting or updating or modifying data, right? So modification of a data, inserting value, updating a value, calls for another set of 4 or 5 different methods that you have to write. So which makes the immutable data structure a lot more bloated than immutable data structure. This means bloated means they're larger in memory footprint and they run slower, okay? So list is fast, but they're pretty slow. Does it make sense? Fast, but slow. Compared to Tuple. Tuple is immutable. When you create a Tuple, you can't change it, and it's only got 2 limited, I think 2 or 3 limited methods that you can ever use. And so that is the, kind of the advantage between the two. Sometimes you have to kind of, decide on whether this is the right data structure for you or not. We know how list is used, right? Presumably you are on part 2 of your game of life, coding. So you should know how list works. Otherwise you wouldn't be able to deliver your prop 1. So what about dictionary? Well, sometimes people use dictionary, and dictionary is used for fast retrievals and storage because your key is hashed. Right. So what is this? Is this a list? Is this a dictionary? Well, this is a dictionary, okay? And there's a couple of telltale signs. First of all, you see key value pairs, right? Key and value pairs, and they're by the commas. And the other telltale sign is the fact that there is a curly braces, right? So this is a dictionary. So this dictionary says iPhone was released, original iPhone 2007, iPhone 5 was released 2012. And of course, when you print this, and then you get, sorry, I think hold on a second. That was Python 2 syntax, so sorry about that. You get your key value pairs printed that way. Now, so some of you ask me, why can't I use list? Well, how do you put this in a list? You have to have two lists, right? So basically you have to have iPhone list, right? So this iPhone list is going to be this, right? And then you can start doing the append and stuff like that, but or you can just put them in here that way, right? So this is kind of like your iPhone, right, list, blah blah blah, and the second one is going to be iPhone 3G, right? So that's list number one, and then you have year list, right? So year list is 2007 and then 2008, because you have to maintain the order. Okay, so this is etc. I'm not gonna keep going like this. So it's gonna be something like this. Okay. Yes, you can turn this entire dictionary into a list that way, but this calls for two lists, and then it is so cumbersome. Let's say if you want iPhone 4S, you want to find out the year, then basically what you need to do is to write a loop or do a search, right? A needle in the haystack to find out where iPhone 4S is, capture its index, and then go to year list and use that index to fetch the year associated with it. This is how many operations here? 4 or 5 operations at the minimum. And if you had to go through that 4 or 5 operation per request, when a user on Google asks you for that info, then your server is gonna go haywire. You'll see smoke coming out of your server in no time when there are a million people asking for the same thing at the same time, concurrent users. That's not gonna scale. So the solution is to use something like dictionary, right? Dictionary gives you a key, right, which is this, and value associated with it. So key and values, they don't have to have a specific data type associated with it. I'm sorry, I don't mean that way. So when I said a key could be a string, in this case, it is a string. It doesn't have to be a string. A key could be, a string with only 1 characters in it. Well, it is a string. So generally speaking, they use string for that, but I believe you can also use integers too. So key doesn't have to be a string per se. In other languages, you can use an arbitrary number to represent your key, but that key has to be mapped, right, to some sort of value associated with it. So the use of dictionary always calls for some sort of mapping from key to value, and then you put them all together. And because all of the keys are indexed in memory, this makes the data retrieval for the value that is associated with any particular key that you wish to get extremely, extremely fast. In computer science, we call it all over one fast, meaning it takes no time. So generally speaking, if something takes like a second, literally no time means 1 microsecond or 1 millisecond, right? That order of magnitude in speed is what we're looking at when we're comparing data retrieval, when we consider that data retrieval is efficient in hash map versus data retrieval out of lists, which takes probably 100 to 1,000 order of magnitude slower than what you would with the dictionary. So hopefully this makes sense to you. And I just wanted to reinforce kind of the idea of the reason why we're using one data structure over the other. And sometimes is by necessity, okay? The fact that iPhone 2007, right? So if you remember last week, when I talked about MLB, team name versus state, yeah, I mean, what else would you be putting these informations into? 2 different lists or 2 different string and array of things? Still, I mean, it's very cumbersome, so you will pick dictionary for that. So sometimes it's by necessity. Sometimes is by virtue of dictionary being fast in data retrieval. So I want to use that. So sometimes you have to kind of work around that problem by changing or transforming your data into something that is suitable for storage in dictionary. So sometimes there's trade-offs between the two. Then again, all of this is going to be, it might be a little too abstract to you, but you'll see, once you get to the next level, some of these use cases become pretty evident, and then you can, hopefully you can get some of the insights. in the current project, because I really think it's a very good project for you to kind of discover these things too. Even though most of your work could be done using list, sometimes people use dictionary, and then you can use list and dictionary to kind of do your own, things. So you can go back and forth that way. Okay. All right. There are 4 primary built-in data structures that we talked about. Actually, no, in Python, we talked about list. We also talked about dictionary. We are talking about tuples today. There's also another one called set, right? Set is a collection of value that do not duplicate. That is the difference between list and set. Not going through set today. Not going through set for this summer. You just be responsible for knowing list, dictionary, and tuple. So let's talk about tuple. So tuple, what is different than list is the fact that list uses brackets, right? Remember bracket? And dictionary uses a pair of braces, but tuple makes use of what's called the parentheses, right? So that's one big difference there between tuples and other data structure from a syntax perspective. So every time you see parentheses, you know this is a tuple. So in this case, this tuple has 3 elements in there. And notice one thing though, when I say tuple, it does not have to be a pair. You can have 4 items in it. You can have 10 items. In this case, you see 3 items. 3 items, they're all strings. You can also have 3 items of integers, right? Each of these values is an integer. And what you can do is you can use 4, right? And in pair. So this y is an iterable, which is the one that you just created right here. So when we're dealing with lists, dealing with tuples, when we're dealing with dictionary, these are what we call collections of things. So you have a bundle of them, right? And these in computer science is what we call iterables, meaning you can iterate through creating some sort of for loop to iterate through every single element. So you get these things out using a for loop. And of course, print gives you that carriage returns, right, that we talked about earlier. So that is true in tuple as well. So you are able to iterate through them, be able to print them. If you just print them as is, you'll see the entirety, which gives you the parentheses and the numbers inside. And of course, you can use a integer, not integer, but a function, apply a function to a tuple. Sorry, my mind just crossed blank. On a tuple to get what you need, which is 9. Okay, so this max calculates, iterate through every single one of these elements and find the biggest one, which is 9, and print it. Okay, so let's move on to the next one. Okay, so the difference between tuples and the rest of the other data structure is tuples and immutables. This makes tuple extremely fast. Why? Because it does not have the facilities for you to write into it, because everything is immutable. It's read-only. You cannot write to it. You cannot modify it. You cannot update it. You cannot delete it. Well, deleting elements inside a tuple, but you can delete the tuples, but not the elements inside of it. So using a tuple, this is list. List is fine because you can do whatever you want, right? You can change it, you can modify, you can update, you can delete, and whatnot. So there is no exceptions. But when you're modifying tuples, meaning you said this second index in a tuple, which is this guy right here, 3, you want to change 3 to a 0, you can't do that. You get what's called not support item assignment error, right? And this crashes your code right there. Same thing with a string right here. String is immutable, just like tuple. You can't change it. Once it's done, you get what's called not support item assignment. So this one is a key error, and this one is also a key error. So you get both these exceptions around time crashing your code. So that's tuple. Tuple cannot be modified. Once you start, once you created it. So things not to do with the tuples. So tuples, you can apply dir directory on top of tuple instance to see what sort of the variables, methods associated with it. But because tuple is immutable, you would expect that most of the features, functions are not available with tuples. For example, sort is not available, append is not available, reverse is not available. you can't do that. You get what's called attribute error, meaning these methods do not exist. So Tuple is really, really lean. It doesn't have any of these that that you would expect, for example, a list would have, but it does not have, right? So what does Tuple have? What you need to do, you can invoke what's called the directories on this and see what happens. So if you do that, then first of all, you need to create an instance of Tuple. So this way of creating Tuple this is what we call dynamic memory management, dynamic memory allocations. So you're asking your program to go inside the memory to dynamically create this empty. And this Tuple here represented a constructor. If you've taken other programming languages, OOP, that's exactly what it is. It's a constructor. So you're invoking this constructor to create an instance of it. It's the same thing with your list. You can see its own methods. So this this Tuple only gives you two methods, count and index. So count is for finding out how many elements you have in there. It's basically asking how many counts, like what is your count for the number of elements you have inside. And as you can see, list also has count in it. But the other index, basically gives you the index value of that particular element that you're looking for inside a Tuple. So Tuple is not really meant for, kind of reading into it or applying changes to it. There's no change you can apply to it to change it. But even from the read perspective, it's very lean, so you can think of Tuple as, comparing to the list as, if the list occupies 5 megabytes, right? I'm just using this as an example, okay? So this is not true. But if this is 5 megabytes at memory runtime, this Tuple might just be 20K, 20 kilobytes, something like that. So this is an analogy, right, between the two in memory footprints at runtime. That the fact that Tuple is much smaller than an instance of list. Okay, so that is a tale of two sequences. Let's also take a look at, in this case, Tuples are more efficient. The efficiency of the two. Since Python does not have to build Tuple structures to be modifiable, meaning it's super lean, there is less memory footprint available that is needed to house a Tuple instance versus an instance that is an instance of list or instance of dictionaries. Both are mutable, but with Tuples, you can't modify it, making it a lot leaner than any other data structures. Okay, so in our program, when we are making temporary variables, we prefer Tuples over lists. Why is that? What do you think that is the case? Besides the fact that they're simpler and more efficient, having a Tuple that is going to be temporary. Temporary typically means that you just wanted to store some data in this temporary stuff, and then later on you can retrieve it and then toss it. You can simply just have them all in there because Tuple might take you 1/10 of the memory in footprint than a list would. So why would you want to use the more expensive data structure to store a collection of value? You can dump the same collection of value, they're all temporary anyway, into a Tuples, right? Versus list. Both Tuples and lists, you can read from it, right? But you don't need to write into these temporary variables. So why not use Tuples? That's exactly what the second point means. Okay, let's move on to the next one. Tuples and assignments. So this is how you do this, how you navigate data in it. So we can put a Tuples on the left-hand side of an assignment. So this means that you can create a Tuple dynamically. So this allows you to do that by having these things on this side. Sorry, hold on a second. Let me use this one. And then what you want to do is you can create a bundle of temporary variables, X and Y, which is basically declared right on the spot. and said that I want to do x equals 4, right? And then your y is equal to Fred, using it this way, right? So when you print this, and then you can do this individually because x and y are both variables, and even though they're sitting inside a tuple, they are variables. So you can take them out there and then print it that way. Same thing with A and B as well, right? When you do the assignment that way. So this is a frequently used sort of methodologies that you see quite a time, quite a lot of times in Python. So the other way of writing it is A, right? And then you have B, right? Without a parentheses, right? And said this one is equal to, right, 99. And 98. Okay, I'm using my mouse here, so it looks very ugly, but you guys get the idea, okay? This is how you're able to kind of, use this sort of conventions to do assignments in tuples. Okay, any questions about this? All right, cool. Let's move on to the next one, tuples and dictionaries here. So recall there's a couple things here. If you're talking about dictionary and the fact that this one is dictionary, hold on a second, let me make sure I have the right. Okay, so D is the dictionary because you're creating an instance of it right here. And with dictionaries, you can assign key value pairs. So what is key? Key is this string right here, right? And then the value is this 2 right here. So you have 2 pairs of key value pairs sitting inside this dictionary. And if you do a D dot items, so we talked about this, right? So what is D dot items? D dot items gives you a list of tuples, okay? It gives you a list of tuples. And what is inside a tuple? Well, the first one is CSAF2, and second one is C12, right? So when you print this out, you can see like right here, and they're printed, and you can see this is a list on the outside, right? This is a bracket right here. And this is a bracket. So this is a bracket. So this items, D items gives you a list of tuples. Okay, so remember that. Now, if you use it in the context of a for in, so remember though, when you have a for in, so what is in? In is inside an iterable. So this is what we meant by iterable. Let me just write this down. Okay, so this is iterable, this the items here, and then for this part is what we call member. So each member inside this iterable. So what is a member inside this variable? Because you have a list, right? So KV is going to be the very first. For the very first iteration, it's going to be the very first tuple. And then the second iterations give you the second tuple. And the third iterations give you the third tuples. So you have these things. Print it one at a time. So the very first tuple is going to give you CSAF2. The second tuple is going to be C14, so on and so forth. Does it make sense? So this means that, yeah, you can convert your dictionary key value pairs into a iterable in order to fetch each individual tuples out of it. Okay, so this is a very frequently used pattern that we do in Python to kind of convert what you have inside the dictionary into a list of tuples. Because what you can do with KV is then you can store them in a list again. But typically you don't have to do that. If you want to do a list, you can just do a d dot items, and to directly get you a list of all the tuples out there. And that's how you kind of convert dictionary into a list, right? Any questions about this one? Okay, the very next one is tuples are comparable or comparables. So the comparisons operators work with tuples. So what happens is because tuples is member-wise, compared in a comparisons operations. So 0 is going to be compared against 5, and then 1 is going to be compared against is member-wise equivalent, which is another one. And then 2 is going to be compared against its member-wise equivalent on the left side, on the right side, which is 2. So as soon as the first comparisons takes place, if they're equal, it goes into a second. But if the very first item is not equal, then you're done. Okay, that's how comparisons work using tuples. The same thing with these things as well. And if you recall, if you do a string-to-string comparison, basically Jones against Jones, right? Sally's against Sam in terms of comparisons. It goes into what's called lexicographical comparison. And this is spelled SO, lexicographical comparisons in string, right? Then there is a set of rules that governs which string is bigger than the other, and you have to basically go in there and do a read on it. But it gives you the ability to compare these things, regardless whether this is integer comparisons or a string-to-string comparisons. Okay, so that's what I wanted to say about tuples and comparables. So any questions about this? I think there's another example of that. Guys, let me just go through this maybe for 3 more minutes and then we'll take a break, okay? So the very next one, let me clear this part. The very next slide is sorting lists of tuples. So what does that mean? You can take advantage of the ability to sort a list of tuples. How do you sort the tuples? Let's take a look. So if you have a dictionary, and this dictionary is represented by this curly braces right here, and this set of keys, right? So K is a key, and 10 is a value, B is a key, right? Value. So this is K1, V1, and this is K2, V2, right? Just to separate keys from each other and value from each other. So this is K3, right? And then value 3. So value 3 is 22. Okay, so you have these, but if you do a dot, the dot items, what do you get? You get a list of tuples, right? So this 8 and 10 is going to be converted into a tuple right here, okay, internally through this d dot items. And this is good news because once you have this list, then remember you can sort a list, right? Sorting means you're sorting it alphabetically from an ascending order by default. Ascending order means the smallest one is going to be the first one, and the largest one, which is C, is going to be the largest one. So lexicographical comparison says C is greater than A because C has a higher ASCII value than B, which has higher ASCII value than C, than A. So A, I think, is 65, if I'm not mistaken, and it's 66. And then this lowercase, I think, is 67. Okay, if not, then this is 97, 98, 98. Okay, so I don't remember the upper lower cases, but you can see lexicographical comparisons here gives you these value. It is through ASCII comparisons. And because you're sorting it in ascending order by default, because sorted gives you ascending order, 65A, which is the key, it's going to be placed first. Remember, when you do a sorting on tuple, you start off with the first element against member-wise the first element from the other tuple against member-wise the other tuple from the third key. So you do these comparisons and you find out A is the first one. So this is how you see after sorting the very first tuple starting with A10 being the very first guy, and then B1 being the second, C22 being the third. Okay, so on and so forth. So this is a sorting list of tuples. So let's do some kind of a quick example of tuples here. And a couple things, let me just delete this and make sure I can still run it because I want to make sure my session is on. Okay, so first thing I want to do is let me just create a tuple, and this tuple is going to be done from scratch. Okay, so I'm going to say I have my BMW. This is a tuple of cars. I can have my Ford. I can have my Tesla. I can also have my Honda. Okay, and then I can have my whatever in here. Okay, so this illustrates, let me see if this runs. This runs. Let me print car. Okay, so what does that tell you? This tells you that in tuple, you can dump anything you want into it. You know, you can have it on a list sitting in there, and something as I believe this also works. I haven't tested it. Yes, you can have an empty list. You can have this list with, you know, some random stuff in it. So what does that tell you? Well, as long as you have a data type that is valid, you can create an instance of it and dump it into a triple, okay? And that as simple as that. So what you can do is you can also find out the length of your tuple. So what do? Print length, right? Length is a function, right, that you can apply. So this will give you, right, 7, right? So there's 7, right? So first of all, I should be using cars, but because I'm putting some random stuff in it, so it doesn't really matter. This is just an illustration. And the second one is indexing. So what you can do is you can also print, you know, using indexing, whichever index you want to print it at. So this gives you 243. So 243 is actually index number 5 because array indexing starts with 0. So BNW is actually 0, 1, 2, 3, 4, 5. So 5 gives you 243. Okay, does that make sense? You can also use, because this is a collection, right? Car is a collection inside a tuple. You can use, when you have slicing, do you guys remember what slicing is? So slicing gives you the, you know, kind of a sub range, giving you a sub collections out of this print, out of this car. So what you can do is, you know, I want everything from 2 to 100. So because 100 is your ending index, not including it, it's already exceeding the size of it. It's simply going to give you anything from 2, which is Tesla, all the way through to the end. So let's run this and see what happens. So you'll basically be getting from anything from 2 all the way to, you know, the very last indexing. So that is kind of that's how slicing works. You can also create another one. Let's say if you want to merge 2 tuples, what you can do is, you know, you can create another one, and this is very low, right? And then you can have, I don't know if you guys ride bikes. I do. Specialized, okay? So it doesn't matter if you have open parentheses and ending parentheses. Let me make sure that this still runs before I continue. Okay, so it does run. So let me just get rid of this. So what you can do is, again, you can create another third tuple. So this is a combined one, and this combined one is going to be car plus bike, and that is simple as that. Okay, and let me make sure I can, you know, kind of print the whole thing to get the merged tuples. So this is how I merge the two, right? Everything that I have inside bike is going to be essentially kind of appended to the end of your initial tuples here, and of course you can create what's called the nested tuples. So what does that mean? You can create a combine that is a nested one. So in other words, I can create another tuple and put my tuple inside another tuple, right? But in this case, what I want to do is a nested tuple of tuples. So if I were to print this out, and as you can see that internally I have a tuple inside another tuple. So each value inside a tuple itself is another tuple, right? So tuple is very, very kind of flexible. In, you know, when you're comparing to lists, you can do the same thing pretty much. And lists could have any data types in it. You can have it listed, you know, another list inside another list. So nested list. So this tuple, nested tuple applies just like you would with this. So the other thing is you can also do a search on it. And so what does that mean? So what I can do is I can forget about this combine. Don't want to do that. I wanted to search whether there is a BMW inside a BMW car. So this is what I'm going to do. I'm going to do a search on BMW, uppercase, right? In cart. Let's see if this is going to give you. So what does that mean? So car is an iterable, right? It's a tuple. So what I want to do is I want to see if there is a BMW spelled exactly as capital B, capital M, and W inside this tuple. Forget about this bike. There's no bike here. Just make it really simple. So remember this in says in this collection if there is such thing. So this is again, going back to 3 weeks ago, we talked about finding a needle in a haystack. Is B and W in this collection? And the answer is true or false. And the answer is false. Okay, so you can do a lot of stuff with it. I just want to make sure that you guys understand, how Tuple goes. Okay, so that said, since we're on the topic, I wanted to show you another thing, which is list comprehension. So list comprehension was on your quiz. I don't think I charged you for it, meaning I didn't give you the points, not give you the points, but make it a, I think I made it an extra credit for it or not. I don't remember, but you probably have seen this before. If you have a, a list, you can write something like this, like for I in range 10, right? So this gives you basically everything from 0 to 10, but not including 10, right? So I'm going to indent it, and I'm going to say, let me see. So what I'm going to do is I'm going to create a square. Square is a list. So I can append this with basically a square root of, from 0 square to 9 squares, and see if this works. And I wanted to print, oh, I forgot to print this. I wanted to print this. Okay, so this gives me a list of square, right? 0 squared to 9 squared, which is 81. But if I were to use list comprehension, I can do something like this. Square, right, equals, and this is what I want to write. And this one is kind of like expression for member in iterables, okay? So sometimes people call it iterables or iterable. So this iterable is my, my collections. So what I want to do is to, let me just rewrite this, right? So what is expression? Expression is a collection of variable with some sort of operators associated with it. So in this case, my expression is I times I, right? For member, so what is a member? Member is one of those inside the iterable. So iterable, we know already, is range 10, right? So range 10 is going to give me is a list, right? So I wanted to make sure everyone understands. So is a list of what? 0, 1, right? All the way through, what is it? 9, right? So range 10 is a iterable. And I want a member of it. So this, what is a member in this case? A member inside each range is I, because that's exactly what I want to do with I squared. So what I can do is instead of using this, I can get rid of this and do it run and see if this compiles. It does. So what I want to do is the print squares. Okay, so I wanted to see if I can use the same methodologies to create the same thing. Okay, so what is the difference between line 7, right, versus line 1, 2, and 3? So 1, 2, and 3 is it's essentially giving you the same result as your line 7, but 1, 2, and 3 is what we call using a definite for loop, right, to generate the same thing. Whereas in just one line of code, using the square expression, bracket expression for member iterable, this is the true, the most basic sort of way you can do a list comprehension. You can use a single line, one line, to get what you need. So this is what we call list comprehension, line 7. Okay, line 7 is list comprehensions. So list comprehension is expression for member in iterables. Just remember that. And there's variations of list comprehensions that you can do. Essentially, you can create something like a, having maybe a 2 list comprehensions in there. This expression, could be, like this, I and J, right? And then for I in, iterable, I don't know, collection list 1, right? So I'm just making this up. For J in list 2, right? So remember, what is very interesting is you don't see any break in between. So you know that this is the first 4 and this is the second 4. And then you can do another if I plus j equals 10, something like that, equals 10. Okay, so this is really crazy, right? Now you can see, by applying expression for memory interval, this is applicable when if you want to do 2 things at a time in a single list. So what this is going to give you is a list of I and j's, and this is available through this comprehension. So it gets pretty crazy from there, and I don't want to get into too many details because I don't want to confuse you, that way, but it is possible. Let me see if there's other examples out there. Yeah, no, I think this is enough for what you need to know. But you don't have to worry too much about this part yet. Just remember what a list comprehension is in Python. Okay, this is a very commonly used methodologies in getting your data in a data structures called list in Python. Okay, all right. So I think with that, there should be plenty of demos so far to help your understanding in how these lists, dictionaries, and tuples work. So this shows you the use of sorted. So this sorted allows you to sort your tuple elements member-wise. So member-wise meaning this A is going to be compared with B first, right? And then B is going to be comparing C in whichever order to find. Basically gives you the lowest in the ascending order, and the lowest one is A, B less than C. So this is how this thing is sorted. Now you can use the sorted elements here. Basically, the sorted result gives you that A10, B1, C22, and you can fetch 4KV. If you want to put them in a parentheses, fine too. It doesn't really matter. But if you put them in a parentheses, that means that your entire expressions here, or the member, I'm sorry, member itself is a tuple, but it is not. So because all you need to do is to fetch K and V individually, right? You don't need to put them in a tuple. So what you can do is you can simply eliminate that parentheses and print the KV respectively, and this allows you to print them all in its ascending order, ascending by the keys. Okay, so key is A, this is smaller than B, which is smaller than C, and value kind of goes with it. So this is one way to kind of use sorted to sort through your entire dictionary. So it is very possible that you have your 8, 10, B1, C22 out of order, meaning this could have been at index 0, this could be at index 1, this could be at index 2. And then if you do the sorted way, you will be able to print 8, 10, as the first one, correct return, and then B1, and then C22. Okay, so any questions about this? All right, if not, let me clear the screen, move on to the next one. So this is the next one, sort by values of key. So I want you to pay attention here too. So what you're doing is you're creating an empty list. So this is a temporary list that you're creating from scratch, and you would append your VK, right? So what is VK? So VK is a tuple, right? This entire tuple is going to be appended into TMP, but because you are starting with V, right, K, you're reversing your tuples here. In other words, your tuple starts with, dictionary, key value pair. So this is K, this is V, right? This is K1, V1, and then this is K1, K2, right? And then V2, and so on and so forth. But now what you have here is in reverse. You're getting a list of tuples, and for each tuples inside this list, you're reversing its order and appending it into a temp. right? So if you print temp, you're getting a list, right, of what? Of tuples, of value key, value key, value key, right? So it used to be key value and now it's value key. So this is how you reverse and then rearrange and transform, right? So you're able to transform your data that way. And why am I doing it? And sometimes you may have to because, you know, maybe you have a, you know, like I said, a, you know, a dictionary that has, you know, car and a year, car and a year. But because they're also random by the year, if you want to rearrange them by the year, by the oldest first, then what you need to do is to do a sort on value. And how would you be able to sort on value? You can't unless you do what? Unless you reverse them, right? Like V and K. And then what you need to do is put them in the sort. And then you set reverse true, right? So if you don't reverse true, then it's going to be ascending. Reverse equals true means you're doing a descending, okay? So the highest is going to be the first one. Highest is 22, right? Because they're in reverse. If you don't, then the one is going to be the first. Like I said, this is a member-wise comparison, so it takes the key comparisons first. If all of the keys are the same, then it goes into the value comparison. That's how that goes. Member-wise means key against key, key against key, right? If they're all the same, then value 1 against value 2, and then value 2 against 1, right? So you do that ordering first, and this is how sorting by value kind of works using the tuples. Does it all make sense? Yeah, I hope it does. So this is this is how you use a for loop, right, to kind of iterate, you know, your key value and say, no, I don't want a key value, I want value key, right? So now you're creating this brand new list, storing in the temp, and you're really, and you're going through all this hassle, right, just to get your value sorted, right, in a descending order. That's what essentially what this is. Like, what is the sorting by value? This is sorting by, oops, sorting by descending order, okay? I have a feeling I misspelled descending. It's probably D-E-S-E-N-D, okay? But you guys get the idea. Any questions about this? I think the next slide illustrates this point as well. Let's move forward to that one and do the same thing. Okay, so you want to find out the top 10 most common words. So let's examine this one line at a time, okay? So we know what the first one is. So by default, this open is going to open romeo.txt. Now the assumption is that this particular Python file is in the same directory as your romeo.txt. And this open is going to be read-only, okay? Because there is no second parameters here specified. By default, you can read from it, but not write into it. So this file cannot be modified, which is fine. You're starting with what's called a pair of empty curly braces. So this is a dictionary. This count is a dictionary of what? We don't know it yet. So what is curly braces? Dictionary is a key value pairs, right? So you're getting a key value pairs, but they're empty, right? There's no key value pairs in there. So what you need to do is for line in fhen. So this fhen is a list of lines, right? And because fhen is a list, it is also an iterable. So you can iterate through every single line using for line in, right? So this line is the member inside this collection. So line, first line, split says, I'm gonna split it by, you know, by default is one to many spaces. So words, it's gonna be tokenized. So first word, second word, third word. So this is a list of words, right? Again, this is no news to you. We went through this 2 weeks ago, incrementally. So now, because words itself is a list or collection of items, you can iterate through every single value inside this collection of items one at a time. So this words, right? Let's say if this entire Romeo text is the top 10 most common words, then your word is going to be the top 10 most common words. So you have an array, basically a list of 1, 2, 3, 4, 5, 6 tokens sitting inside the array. And every token inside the array will be ascertained using word, right, as a member inside the collection. So word for the very first one is the, right? The second word is top. The third word is 10. The fourth word is called most. So you have count, whatever this is equal, right? This. Do you guys remember what this is? So if I do a count and get, so count is a dictionary, right? So this dictionary says, I'm going to create this key, right? And this key is a number of occurrences. So the very first thing you do is you do a get. So if you do a get on count, which is a dictionary, you're getting the number of occurrences or whatever the value is associated with this word first. If the word does not exist, by default, gives it a 0. So this allows you to increment the number of counts, right, on the occurrences of word, because you're incrementing it by 1. This allows you to store how many times this word has occurred. So if this is the second time that the word has occurred, then count.get word, colon a period is comma 0, it's going to give you 1, right? Because this word has appeared once before, and this is the second time that it is appearing. So 1 plus 1 is going to give you 2. Then this word, if occurred again, it's going to get 2, right? So this allows you to have a fixed, key associated with the value, right? And this value always changes, right? Sometimes you have value plus plus, plus plus plus. So you just keep going. And then the second key, let's just make it, this is key 1 and this is key 2. And then you can have key 3, right? So on and so forth. And then value 2, and then value 3. Okay. Yep. So and then they will be stored inside this counts dictionary. Okay. The counts dictionary is going to have key 1, v1, right? Forget about this one. Let me just undo this. There's no more of this. Okay. So k1, v1, k2, v2, and k3, v3. So all of these will be sitting inside what's called a dictionary. So this is a dictionary, right? And what is this? This is your count. Okay. This is your count right here. All right. That we're done. Now let's move on to the next one. So this next blocks right here, this says list, okay, LST. It's an empty one. But what I want to do is I want to do a count.items. So we talked about this. So what is one count items? By default, this is going to give us a list of tuples, right? Okay. So the list of tuples is going to have for each tuple, this is going to be a key value. What I want to do is I want to reverse it, right? I want to say value key first. So this gives me a list of tuples in the value, arranged by values. And because they are not sorted, they're basically by the order. So if the very first items inside the count is then I'm going to get the value of it, right? The value could be 1 in this case. So 1 is going to be first, and then because they're first come, first serve, dot append says appending this entire tuple at the very end of a list. At the end, your LST, your list, is going to be a list of tuples. And like I said, when you're dealing with tuples, you can sort them. Okay, so this entire list of tuples is going to be arranged in a descending fashion. So reverse equals true is descending. Descending as in the largest value. Excuse me. It's going to be the first one. No, actually, yes, the smallest value is going to be, the largest value is going to be the first one, okay? Because you're doing a reverse. If you don't do reverse equals true, or by default reverse equals false, then you're going to have the smallest one because everything is on ascending order, right? So the value is going to be the smallest first. But because you're reversing it to be true, your largest is going to be the first guy. Your largest val, right? It's going to be the first one. But because you said the top 10 most common words, what you need to do is to print in this list anything from 0 all the way through what? All the way through 10, but not including 10. So it's 0 through 9. So this gives you the top 10, the most occurring words in this entire list that you just ascertain using this, right? First of all, you do a count, and then you create the list to rearrangement with the purpose of sorting it, right? And this allows you to sort them in reverse order. And basically, because they're in reverse order, the largest value is going to be the first. All you need to do is just take the top 10 out of this list and then print them in a regular order key value pair out there on the screen one at a time. Does it make sense? So I know this might be a little confusing. Don't. If you, I'll challenge you to keep going this and be able to write this if you can. Take a look at it, study it, make sure you understand it, and then close this page. Okay. I want you to do it from scratch. Do it from memory. You know, do it from scratch, and don't do this. What you can do is you can set fhands to be, you know, a list of lines of texts that you put in there. Okay. So you can pretty much just write them out there. So there are 2 lines. So just make sure that you have them in the fhand. So this fhand is a list of lines, right? A list of text. So this is a string right here, and this is also another string. So you can dump these 2 strings into fhand there, and make sure they're in the list. That way you don't have to go through this again. But the choice is up to you. I just want you to be able to write this from scratch from the very beginning, without aid. Okay. Without copying from someone else's code, without, you know, peeking and try to cheat. Do it from scratch. See if you can get to this part. Okay. So I want you to be able to understand this. Any questions about this? No. Okay. Well, let me move on. So this is the list comprehensions. I'm so glad that we just went over it. List comprehension is much shorter version, and it's so list comprehension is extremely fast. This is already optimized in Python runtime. So if you were to write for loops and then, you know, go through what we had before, much slower than this. This is very, very fast. So you have your dictionary calling for A, B, and C, and they are looks like they're sorted. Now, what you can do is you can create this. So what is this? This is an expression, okay? This very first one is what we call expression. So this expression is just a tuple, right? This is expression, which is tuple. Okay. Now, inside your for loop, so what is for loop for K, V, and C items? So for loop, the very first one, KV, is what we call member, right? This is a member of what? A member of the collection. So C items is what we call iterable, right? Because C item gives you what? C item gives you a list of tuples, right? So you have this list of tuple as an iterable, as a collection of sorts. So I'm just gonna eliminate whatever the key value pairs are, not the key value pairs, the tuples itself. But you know there's tuples here. There's more than 3. It's A10, B1, and C12, C22. For this iterable or collection of things, KV is going to point to directly into each tuples K and V, right? Key value pairs inside this tuple, and form a VK. So this VK is the key value in reverse order. Inside of it, you'll get B. You get 1B, 10A, and 22. And what is really nice about this is you're doing a natural sort, right? Natural sort meaning ascending order. So the lowest value that you have inside this collection or iterable is in an ascending order. It's going to be the first guy, and then 10 and 22. And the reason is very simple, because this is ascending order. Memorize comparisons on the keys, because they are different, calls for 1 being the lowest, 10 and 22 being the highest. So this gives you the ability to do a couple of things. Convert the entire dictionary into a tuple, a list of tuples, and using list comprehensions, you're able to fetch, right, individual value key in this case, and immediately after done, sort them in ascending order. And this allows you to print 1B, 10A, and 22C that way, right? Now, if you want to have more information on, want to get more information on list comprehension, there is this link right there. And also, I'm sorry, this is not list comprehension link, but this is a sorting link. But I want you to do is there's a whole bunch of reading on list comprehension, and I gave you them. I gave you this list comprehensions in the videos too. So you should have you wanna be able to review this and make sure you understand it before you move on. We went through tuple syntax, right? So tuple syntax is a collection of parentheses. It's a parentheses with a collection of value with a comma delimited. We learned a couple of things. One is inside a tuple, you can have any data types as long as these are all separated by a comma, right? Then you can form a tuple. Tuple does not mean two. It can have 3, 4, 5, 6, 7, 8, right? We illustrated this. That's tuple syntax. Tuple is extremely fast. You can dump stuff into it. You can quickly retrieve them because tuple itself is not mutable. You cannot change it later on. Once tuple is created, it's fixed. This makes tuple super lean in footprint, which means it's super fast in terms of putting data into it, in terms of data that you want to read off of it, right? Not modifying it, but read off of it. Super, super fast. And because tuple came with a very, very useful feature allowing each member, when you're doing with tuple comparisons, tuple left, tuple right, comparing both, it's comparing each element one at a time. So it takes out the very first element, which is at index 0 on both sides, do comparisons there. If there is a determination that could be made, then that would create the comparability, meaning the true or false. And given that, you can then sort, because sorting itself makes use of the comparability of your elements inside tuple. So these things kind of came close to each other. But because you already have this thing called sorted function available in Python runtime, you don't have to write them again. Okay, so sorted is available for tuple instances. So you can have a tuple instance and have them all sorted, but this gives you ascending order by default. If you want to have a default, if you want to do a descending order, for example, then you want to say reverse equals true. Okay, this allows you to reverse the sorting directions, making sure that the highest value goes first. So a lot of times you want to find the top 10 or something. Top 10 always means the most, right? Whatever that value is, the most occurrences or the highest, the most expensive, whatever that is. This would allow you to pull the data out of its wazoo and transform and order them. So that's how tuple is used most of the time. And of course, you can make tuple, you can insert tuple in list comprehensions as well. It depends on how you want to organize your data, so to speak. So this comprehension is just a way of kind of massaging the data and transforming it into different shapes and forms. In data sciences and machine learning, these people make use of these data types. When I say these data types, string, list, dictionaries, and tuples, even set, okay, which we're not going to talk about interchangeably. So you see list comprehensions, which is extremely fast operations that allows you, and is native to Python. It allows you to quickly come to terms with a group of values that have no structure, and then and through this arrangement, you're able to kind of put them all in an orderly fashions to allow for better better viewing, better assessment, and also better retrieval in terms of the data management in Python. We spent the last 15 minutes or 20 talking about sorting dictionaries by either keys and value. Like I said, there's only a limit as to how much I can explain the certain things. This lecture is recorded. You should go back and just double check on the sorting dictionary by keys and values, and make sure that let me just erase this part. Make sure that you understand these things, okay? And I want you to do an exercise. Once you get this, give this a read, okay? This entire thing, okay, right there. Try to write its code. Now that you know the principle, write its code without looking at it, okay? Maybe 10 minutes later, just give yourself some time, right? Read it, And then maybe use a pen and pencil. You don't have to write them all on an IDE as well, but make sure that you can memorialize this whole thing to see, how this works. Because if you don't do that, then there's no point in, just just listening to my lecture, because that's only limited in terms of your retentions. You have to do it by hand. So that's my recommendation. Okay, kind of a homework for you to do at the end of this lecture. So anyway. This completes the summary portion of Tuples.